We've made it to 10.6a in Algebra 2. We're going to talk about how to recognize equations of conic sections. Those are sections of a cone, and we've really compiled a lot of videos for Chapter 10. There's 19 now, so you can just click on the description to see any of the previous videos. Now, it's important to be able to look at a second-degree equation and tell whether it's the equation of a circle, an ellipsis, a hyperbola, or a parabola, and we have some clues. So here's our clues. In this equation, you can see that this is second degree, that's second degree. There's a little 1 exponent that's invisible here and here, isn't that? So that's the first degree, and then we have our constant. If the a term and the b term are equal to each other, the equation may define a circle. So if that's a 5 and that's a 5 and they're both positive, it may define a circle. If a and b have the same sign, so if that's a positive and that's a positive, or that's a negative and that's a negative, as long as the a and b aren't equal to each other, the equation may define an ellipse. If a and b have different signs, negative or positive, the equation may define a hyperbola. And if either a or b is a 0, it may define a parabola. So if the a term is missing, that means a is 0. If the b term is missing, that means b is 0. Okay? So we covered these in these videos, and there's all the links in this description if you need to see them. These were the standard equations for conic sections, and the centers were at 0, 0, the origin. So this is the ellipse, this is the circle, this is the hyperbola, and that's the parabola. We just finished doing that. Okay? So these are important because they're going to help us, all right? Equations representing closed figures like circles or ellipses must be checked to make sure real solutions exist. So an open figure would be something that has an opening on one of its sides. A closed figure is completely closed off. There's no escape. If you put a horse inside of that pen, it wouldn't be able to get out, would it? But it would be able to get out of here because it's open, all right? So for a circle, we have x squared plus y squared equals r squared. If we saw an equation where x squared plus y squared equaled -1, well, there's no real solution. X squared and y squared are non-negative, okay? They're either a 0 or they're positive. You can't add 2 positives to equal a negative. That wouldn't make sense, would it? All right? So we can tell which conic is defined by each equation. We'll look at the red a value and the blue b value. This a and b have different signs, so it's a hyperbola. Because the rule said, the clue said, if a and b have different signs, the equation may define a hyperbola. That's a positive and that's got a negative in front of it, doesn't it? For this one, if either a or b equals 0, the equation may define a parabola. Well, look, there's no by squared here, so that means it was a 0. There's no y squared term. So this equation defines a parabola. Now take a look at this one. We have a positive 2 and a positive 2. Okay, so a equals b, so this equation may define a circle. All right? That's the rule. If a equals b, the equation may define a circle. But we need to complete the square to check this. So here's our equation, and what we did was we added a -1/2 to each side of the equation. So it wasn't set to 0 anymore. It created a 0 pair, additive inverses here. So now we have a -1/2 on this side. We complete the square. Remember that it's times 2. So we get a 9/16 on this side, and it's times 2. We need to add it to this side to keep the equation balanced. We add these together, we get 5/8. Now after completing the square, the right side of this equation is positive. So real solutions do exist. The equation defines a circle. So the circle said x squared plus y squared equaled r squared, and they needed to be positive, and it's positive, so it works. Okay? Our next video, 10.6b, we're going to find second-degree equations from graphs. I'm going to add this to the Algebra 2 playlist, and there'll be a link to those previous 19 videos. All right? If you're having any trouble with any of this, it's just a click away. We covered all of this, and the videos are in this description. I don't know how to make it any easier than that. Good luck, and I'm proud of you for trying. See you next video. Bye.